Good morning. Today's lesson is the second fundamental theorem of calculus. Okay, we're going to talk about a function f of x and it's continuous on the interval ab, and we're looking for the derivative of a function that's defined as an integral. There was one of those on our bottom of our notes last time, and all we did was evaluate it. Today we're learning to take a derivative of it. You're like, why am I learning to take a derivative of an integral in the middle of a unit on integration? Well, we couldn't learn how to do a derivative of a function defined this way until now because we didn't know how to integrate. All right, but before I fill in the blanks here, I have another version that I want to talk about first. So I'm going to scroll to the bottom. You can follow along. And I'm going to do a little refresher so we remember how to integrate. I'm going to integrate from 1 to 2 of 3 over x squared minus 1 dx. Okay. And I'm going to rewrite that as 3x to the negative 2 minus 1. The antiderivative, you subtract 1 and, you add 1 and put the new derivative at the bottom. And I'm going to evaluate from 1 to 2. Let's clean that up. It's negative 3 over x minus x from 1 to 2. So I end up with negative 3 over 2 minus 2 minus negative 3 minus 1. And you end up with negative 7 halves plus 4. It gets you to a half. All right, so that was just a refresher on integration. Had nothing to do with today's lesson per se. Now, let's turn this into a function that's defined as the integral from 1 to x of 3 over x squared minus 1 dx. And since we just did this, we know the antiderivative is right here. Okay, so I'm going to fill in my antiderivative. So it's negative 3x minus x, and I'm going to integrate from 1 to x. So you plug in your x, you get negative 3 over x minus x. You plug in 1, you get negative 3 minus 1, and your answer is negative 3x to the negative 1 minus x plus 4. Okay, so I evaluated my function. Now what the second fundamental theorem of calculus says, it says take the derivative with respect to x of f of x. All right, so here's f of x. I did the math and ended up with this answer. So they want me to take the derivative of that. Okay, so it's So it's d dx, for those of you that were stealing stuff off the internet. Sorry. So now you got to remember how to do derivatives. You wrap your exponent to the front, so it comes 3, and you subtract 1. The derivative of x is negative 1. The derivative of a constant is 0. Okay, so that gives me 3 over x to the negative 2 minus 1. My question to you is, how does this compare to this? They're exactly the same. Okay? The difference being up at the top of this page, instead of that, they put a t in there and a t in here. So you're plugging x into the function that's in terms of t. So this is a real easy thing to memorize. It's not a hard thing to do once you memorize the steps, but the question is, why am I doing it? Okay? And it's because you're learning to take derivatives as a function that's defined as an integral. And our next unit, one of the first things we do is you've got a function. It's defined as that, and you're going to integrate from 0 to x. So you integrate from here to here if x is 1. You integrate from here to here if x is 2. Integrate from here to here if x is 3. And you have a moving target. Okay? That's where we're going, but not today's lesson. Today's lesson is pretty straightforward, and you go, oh, why did you teach me all that other stuff when all I had to do was memorize this? Because I like you to learn a little bit besides memorize. All right, so I'm trying to take the derivative of this function. It's in terms of t. So I'm going to take the derivative of that, and then I'm going to use the fundamental theorem of calculus that says it's f of b minus f of a. And b in this case is x. Well, when you take the derivative of the antiderivative, you get back to the original function. Okay? And the question is what happened to the lower bound? How come I don't have anything written down for that? Well, when I take an antiderivative and put a value into it, because that's a number, then turn around and take the derivative of a number, you get 0. Okay? Like down here. We took the derivative, you got a constant. The lower bound gave me a constant. You take the derivative of the constant and it's 0, so it's not part of the problem. All right? So let's go back to the top. You sick yet? Rolling up and down? You don't have to know your antiderivative or anything. I'm taking the derivative of that function, and the answer is cosine of x. There's no plus c, nothing. Your constant went away because the derivative of the constant is 0. Come over here, you get 1 minus x cubed. So what happens here? Dun, dun, dun. The answer is x squared minus x. And that's all there's to it. It's like, oh, I could memorize that. But I wanted you to at least have an idea what we're doing. You're taking the derivative of a function that's defined as an integral. All right? Then it says, what happens if this is a function? Well, I'm going to take the derivative. I'm going to have the antiderivative of h of x minus the antiderivative of the lower bound. Then I take the derivative of that. I'm taking the derivative of a function with a function. You go back, and what did I do here? X squared minus 1 cubed. It was 3x squared minus 1 squared times the derivative of that. Chain rule. So this is times h prime, and that's still 0. Okay, so when I do these problems and this is more than an x, my answer is, 3x squared minus 3x times the derivative of that, which is 3. So this ends up being 3 times 9x squared minus 3x, which is, what, 27x squared minus 9x, and that's your answer. Okay, same here. You're going to plug that in. You get the sine of x cubed squared times 3x squared. So we get 3x squared sine of x to the 6th. Not bad. Your turn. You plug that in, so you get 2x squared cubed minus 5 times x squared, all times 2x. So you get 2x times 2x to the 6th minus 10x squared. You can keep going if you want. And it says, well, what happens if the lower bound and upper bound are both functions? Well, when you take the derivative, you have the antiderivative of this function, and you're going to take the antiderivative of the next function, and so we're going to do the same thing. You go back to the original with the function plugged in, and then multiply times its derivative because you're using the chain rule, and then this is going to be f of g of x times g prime of x. So here's my function. You plug it in, you get the tangent of 2 times 5, oh, hang on, that's messy. 2 times 5x times the derivative of that, which is 5, minus tangent of 2x squared times 2x. I just put it in the front, it's easier. So that's 5 tan 10x minus 2x times the tangent of 2x squared. And that's all there is to the lesson. I added this part down here just to help it make a little bit more sense. I hope that helped. Thank you.